The first step here is alignment adjustment procedures. For the 39,000 and below, you're going to have to adjust the 8.1 volt power supply. All right, the 8 volt power supply. And the specification is really confusing because it's known as the 8 volt power supply. And if you look at the power supply cover, I'm going to pull off here and show it to you. It says 8.1 volts. But the specification is 8.2 volts in the manual. Okay, so somewhere between the engineers and the manufacturers and everyone else, they got all kinds of confused. All right, so what we're going to do is align the 8.2 volt power supply, and we're going to do that here. And you're going to have to do these things two-handedly. Sometimes you need 3 hands for an alignment. All right, first thing we're going to do, I don't care whether the radio's hooked up or anything, I just want power on. I'm gonna apply my power, and I'm gonna turn on my radio, and I got it working, right? I've got my multimeter set up, DC volts, 20 scale. Ground lead is grounded at the panel, where it should be. And then the positive lead, I have a Sharpie probe. I prefer the Sharpie probe for in-the-box work. I'm going to go over here, and if you look at the 8 volt power supply, on the front end of it, there are 4 filters. 3 of them are set to 8 volts or so, and the 4th one is 28 volts. So you can pick any one of the 3 and measure on it. And I'm reading 8.14 volts. This next one I read 8.19 volts. 8.19 volts. They're all pretty close to 8.2. It'll take me an alignment tool.
Okay, what are those things called again?
They're filters.
Filters, okay.
Okay. So I got 8.14, I got 8.19, I got 8.19. I'd like to get them all close to 8.2. So go ahead and turn it a little bit and maybe increase it just a bit. Just a tiny bit. Okay, so I've got the ones that were a little higher at 8.23 and the one that was a little lower at 8.18, meeting my specification of 8.2 plus or minus 0.7 volts. Okay, which is like quite literally 7.5 to 8.9. So I was well within spec. But what did I do? I got it as close as I could, because this is an event, all right? You've got this radio open on your bench and you're going through it from one end to the other. It's an event. You want to make sure everything that you do is done properly and completely, okay? You don't want to go, well, you won't be a lazy technician. You can go look at that and go, oh, that's close enough. All right, that's close enough gets people dead. I used to say it nicely. I don't anymore. Okay? You want to get it as close as you reasonably can. If you can. If you can't, you want to get it within specification. Because close enough still passes a final inspection. But if you can get it dead on, that's what you want to do.
That 4th filter you said was at 28 volts?
That's the 28 volt input line.
Oh.
So if I probe it, I go overload. To go to the higher scale, that's where your input to your power supply comes in, 28 volts. Okay, that's straight line voltage from your off the on-off volume switch. All right, so that was the 8 volt power supply alignment. It's a power supply alignment. Learn how to do it. You just set it to a specification. It's that simple, all right? Our very next alignment is the COM synthesizer alignment, okay? So we got to perform some preliminary test setup procedures. So plug the radio in, turn the radio on, set your test setup. You've done this for initial inspections, right? There's some preliminary setup, okay? So I'm gonna hook up the COM. I'm gonna inject 1,000 hertz, 30% modulation. I don't even need to use the master mod. I can put it in a lock spot, okay? Probably 50 microvolts. 100 soft, 100 hard, 50 soft. Okay, we all know about those things, right? And I'm gonna set this up so I'm receiving with the comm speaker. You know, if I want to hear it receive, I can. Okay, all right. I don't want to hear much of it. Makes my hearing aids ring. So, connect frequency counter. Oh my, what? We're gonna use a frequency counter? Conveniently in your panel, there's a frequency counter, and most of them work. Matter of fact, I spent and took a little extra time this last semester break and fixed a bunch of them. You want to go to frequency on your frequency counter, okay? The frequency button sets the frequency counter to use channel A, which is on the bottom. Okay, for frequencies on this one, it's between 8 hertz and 125 megahertz. So we're going to read most everything. If we need to read a higher frequency, we can go to channel B and you have to select it there. Okay? And then you want to leave it always on auto. Leave it on auto. Let it do the work. All right? Of all the pieces of equipment that I want to auto scale and auto measure and auto do things, the frequency counter is it. Okay? I want it to do its thing. You're going to hook an O-scope probe to it to make this measurement. Right? And it says connect frequency counter and then just connect it to A3TP7. Well, what we're measuring here, there's a couple of oscillators in this radio. There's a voltage controlled oscillator, your VCO, or your local oscillator, which is the same thing. And those control that synthesizer input to your receiver that we covered just a few minutes ago in the lecture. Okay, well, that needs to be compared to a reference. Your reference oscillator is what we're going to align first. Okay? And that is quite literally this metal box right here. Okay? You'll see it has reference frequency adjust, and it has reference frequency with a test point. That is test point 7. And if you look in the hole, there's a little post sticking up in there to measure from, right? So what are you going to do? You're going to try and probe that with your O-scope probe, right? Wrong. You can go to my little drawer over there on the top left drawer in the cabinet and pull out one of these little jewels. It's got a socket on it, standard D-sub socket, and a clip that conveniently clips to the end of your O-scope. You're going to use this a lot, so learn how to use it and get familiar with it. You will always have little test jigs to use on the bench. This is one of them. Ground your O-scope and take this with this rig, making sure your probe's on ×1, and probe TP7. And then hopefully you can get down on that little post and it'll sit there. Now be very careful because anything exposed might get grounded out. All right? So once you get that there, you'll see on your O-scope, on your frequency counter, I have a frequency. I am supposed to adjust C72 for a frequency reading of 3.2 plus or minus 25 hertz. Well, I'm not in spec because that ain't 25. All right. This is 3.2 megahertz. Okay. So that's kilohertz, that's hertz. I'm out of specification. What you want to do is get this as close to 0 as you can get it. So here's an important alignment point. What's the difference in tolerance between 3199999 and 3200001?
2.000.
It's no difference. You're one below and one above. Okay? So if you get to 3199999, you're good. Or you're well within specification, you're almost dead on. If you get to 3200001, you're good. All right? Understand. It's the same thing, you're just below or above. Because it says plus or minus on your alignment, right? So I'm going to take an alignment tool. I recommend a non-metallic alignment tool if you have one. Your alignment tool kit, this one's short, the one I really need, because it's got one with a metal tip that sticks out. Someone absconded with that a couple of semesters ago. Pisses me off. Filter that out of the final.
Yes.
Thank you. So I'm going to use a small screwdriver and very carefully turn that until I get something that looks like what I want. I'm within specification. I am well within specification. Matter of fact, that's almost perfect. I would fly that. I would let that pass. That's well within spec.
Whoa.
The thing about this one is, most often, if you're careful, you can get it dead on. And you notice it's got a momentary delay. Why? It's counting. This is a frequency counter. It's got to have time to count. Okay? You do math in your head, right? Sometimes. I mean, you can look at something and say, there's two of them. 1, 2. Okay? But it took you time to do that. The frequency counter takes time to count that, right? That extra moment it needs is the delay you see in the alignment. So turn it a little bit, see where you're at, watch it, okay? That's well within specification because it's plus or minus 25 hertz, right? That's almost perfectly dead on, and that's the goal. All right? So that's the synthesizer alignment, right? Well, that's the first part of it. So when you're done, here's another theme you'll hear me talk about a lot. When you get done doing a thing, get out of it. Don't just leave this stuff hooked up because it's going to be in the way. So you're going to disconnect it and get out of it, right? Because we're not going to use it again for a little bit. So the next step is connect my vacuum tube voltmeter to TP9. Okay, that's not a vacuum tube voltmeter. All right, but that's what the specification said. And I got to get to TP9. Well, TP9's in this wonderful place. It's underneath this card. So I got to turn this thing off and open up my receiver. I'm going to take off the 2 screws on the left side. Do not ever take off the 2 screws on the right side because they go to these hinges. And there's this little ribbon cable here. And if you damage that, you're going to have a significant emotional experience when you solder the 22 solder points that is required to replace that ribbon cable if you break it.
I did that.
What?
Took off those 2 screws you told me not to.
Yeah, and you were lucky.
You said
I've got
Sometimes you got lucky.
2 on the left?
Yeah, these 2 on the left. If there are screws on the right, this one's a solder version. This is an older version of the radio. The newer versions have screws. Don't ever unscrew them. Okay?
All right, let me see what you did here.
I just took these 2 screws out.
Oh, this is for the comp?
This is for the comp. Because if you look on the, remember these 2 screws on the disassembly lab? Those are the 2 you don't want to take out because they hold the receiver board in. Open the receiver board like a book. You now have access to the voltage controlled oscillator. All right, and you should see this one's actually labeled TP9. Someone wrote it on here. In the voltage controlled oscillator is another one of those fancy test points that you need the test jig for. Okay? So what we're going to do is set it up and set up our multimeter to measure DC voltage. Okay, and I want to measure the output of the voltage controlled oscillator. So I'm going to go ahead and hook this up. And I'm using the Sharpie probe. You could use a regular probe. Again, I prefer the Sharpie for in-the-box work. Now I got to be very careful because that's hot when I probe this. So I want to make sure I don't lay it on the chassis because it'll blow up my VCO. All right. Now I'm reading 6.7 volts. So the very next step, I have a note written here because I'm going to close the microphone key. I'll talk about that in a second. And I'm going to adjust this inductor. Okay? It's got a little slug in it. You always want to use a plastic or ceramic alignment tool on those slugs. Okay? Your alignment toolkit comes with one that fits the slug. All right? All right? I'm going to use the ceramic because I've got various size slugs in this. So I don't want to keep swapping alignment. I have these in the lab too if you want to use one. I recommend you have your alignment toolkit though. That way you always have a tool. So the very, this inductor, if you get one that comes out of an airplane, the manufacturer sealed this with beeswax. So it don't move, because this is a super important alignment. Okay, it sets the frequency for your voltage controlled oscillator. So if you need to remove the beeswax, you get a heat gun and warm it up and scoop out the beeswax, make your alignment, and then you take your beeswax that you scooped out and put it back in there and reheat it to reseal it.
That's cool.
You should not run into any of them in the lab that still have beeswax in them, because I've removed it so that we can perform our alignments, right? Step 6 says close microphone key. So what does that mean?
On the panel.
Yeah, what else does that mean? What does that mean? It says close microphone key. What do I got to do before I close the microphone key?
Turn it off.
Open.
No,
On that.
no. What am I doing when I'm closing the microphone key? What am I doing? I'm
Grounding the microphone.
I'm grinding the microphone key. What else am I doing?
Turning it into that position.
I'll be closing the microphone key by flipping that switch. What else is going on here?
You're applying voltage to different places.
Okay,
Volts.
that's a true statement. That's not what I'm looking for, but it's a true statement. What am I about to do when I close the microphone key?
Turn on the microphone.
About to change knowing.
I'm about to do something, and I need to change where I terminate my cable because I'm going to transmit. Oh my God.
Wow.
So you need to make a note to yourself, you're transmitting here. So you need to put your transmitter into the proper termination, whether it's the TR port on the 500A or the input to the 401L. You need to transmit into a proper load. Now, I'm not looking at that test set to do anything at this point, but I need to load the transmitter. And I do not need to transmit into my NAV750. You'll blow it up. And then you, as I've stated before, you'll have a significant emotional experience when you get to go into the bowels of it and give it a colonoscopy trying to get to the op amp you blew up. Okay?
I'll mute that part.
You don't have to.
Mutes in there.
All right, don't mute that part. 'Cause all right, so I got to transmit. So that also means I got to observe duty cycle, right? Why are we transmitting? Well, this is part of the alignment lesson that you didn't get yet, but you got to get the local oscillator to generate, or the VCO to generate the lowest frequency, right? That's why we transmit. So, and when it generates the lowest frequency, it's going to generate the lowest voltage, and this is a voltage controlled oscillator, so that 2.75 volts specification is keyed to 118. All right? And as it goes up, step 7 says open microphone key and turn to a different comm frequency, and it should be about 15 volts, right? That's the high end. And you only generate the high end of the VCO when you're receiving, okay? And you'll see in italics, I've also said many manufacturers set the bottom end and just check the top end. That's an industry standard. That's an industry best practice. So the manufacturers will set one end and check the other, okay? Just the way it's done, all right? So we're going to go ahead and transmit, and I'm going to observe my voltage when I transmit. I want to see 2.75. Notice the specification is 2.75 plus. Not plus or minus. That's not a typo. That's quite deliberate. 2.75 plus 0.25 minus 0.0. So it has to be at least 2.75, but it can be more, up to 3, right? And you want to set it within that specification. In reality, I'm telling you, you want to get it as close to 2.75 as you can without going lower.
Oh boy, the anticipation.
Oh yes, I haven't keyed the radio yet.
I know, I was like, I'm sweating here, I'm waiting.
So now I'm properly terminated and I'm going to transmit. And I get 2.82 pretty consistently, right?
Satisfying.
It's well within specifications. Do I have to touch it?
No.
No. Is it good enough? Well, that's good enough. That is not as good as it can be. It can be 2.75. So you get to align it just a little bit. So I'm going to tell you a cheat. I read 2.82. You notice my numbers were important, right? Which is 0.07 of a volt higher than 2.75, right? I did the math in my head, right? I picked the number out. I saw 2.82 pretty consistently, so I'm 0.7 of a volt higher. I'm going to go ahead and turn this until I'm 0.7 of a volt lower, so I don't have to constantly transmit and align, because then I got duty cycle problems, right? So I'm just going to go ahead and tweak that down about 0.07 of a volt. It's the wrong way. Okay, that's pretty close. Hey, that's dead on. Notice I just barely tweaked it. If you get to a point and you're spinning that, any of these inductors, you're screwing it up. These all should be close. Should be, all right? If you turn this inductor too much clockwise, because everyone starts and they turn it clockwise, that screws it down in through the board, and it will eventually bottom out or fall out. And then I have a significant solder job to go retrieve your slug. It's painful. Don't get screw happy in these radios. That was meant for alignments too. Alignments are generally minor adjustments. There are a few times that they're not, but generally they're minor adjustments. All right? So you see I dropped that 0.7 of a volt, or 0.07 of a volt. I'm gonna key it up. Hopefully I see 2.75. I didn't drop it as much as I wanted, but I'm a little closer. I can take it down just a tiny bit. Now, something else you can look at when we're doing this, let's see where we're at. You got this test set. Yeah, we're still a little off rate. You got a test set that measures frequency while you're doing this, so you can tweak this a little bit. All right.
Oh, that was good.
And hopefully you get 2.75.
Nice. Okay.
That's pretty close. It's actually too low.
Yeah, we need to.
-0.
6 point.
Okay. I'm mostly bouncing right around 7.5. And I'm still off frequency a little bit, but I go to the 3 scale. You can see it on the 500A. I'm less than 1,000 hertz off. It's probably good. And I'm transmitting, so I'm close. I have aligned the low end of the VCO. Now I'm going to check the high end. All this is a check. I should see less than 15 volts. I see 11.3. Check. I checked it. That's the synthesizer alignment.
You just changed frequency.
All I did was
What
change
setting are you on?
frequency.
7.
7.
Open microphone key.
Yep. Open microphone key, sitcom frequency to 135.975. So the step-by-step procedure in the manual, and this is copy-paste straight out of the manual, okay, the way they tell you to do it. Did you see that I didn't follow that procedure exactly?
Yeah, because I'm writing all the stuff that you're
I
saying.
modified it just a little bit so you can observe duty cycle and you can do this quickly. Okay? I'm protecting my radio, protecting my test equipment, and getting through it fairly quickly. This should go really fast in real time. Okay? But did you see how to align it? You had to set the reference oscillator to 3.2 megahertz very accurately, and then you set the voltage controlled oscillator on one end you set it so it'll generate the lowest possible frequency, and then you check it on the high end, right? See how that works?
So that's like a linear.
Yeah, it's a linear thing. As I go down in frequency, you'll see that voltage change. Each of those voltages is approximately equal to the frequency that you see. And if I change the kilohertz, it changes as well, okay? For the voltage controlled oscillator voltage, all right?
So you went to 136? Or...
They're 135,975, just like it says on the handout.
Oh, I got a question for you since you got on the open mic. Now, you've got that on 135.975. So what would the voltage be at if you decided you wanted to transmit?
That's a good question. 135,975. There's no specification given. Okay, it's going to be approximate. I'm going to guess that it's going to be somewhere around 7 volts, 6 something ish. We'll see what happens. I have not actually done this. Okay, it's 6 volts. Okay. So 6 volts is equal to 135,975. 11.3 volts is equal to 154,375 or whatever the high end out of your VCO for your receive function. Same circuit, generates your transmitted RF and generates the local oscillator for your receive function to go to your mixer, as we learned this morning, right? All right, that's the synthesizer. So we've set our power supply and we set the synthesizer. Now we need to check our audio levels, okay? So we're gonna get out of this test, which is real simple. Just disconnect the stuff. Apply 1,000 hertz tone from the NAV 750. Now, this is straight out of the manual again. It doesn't tell you that you need to be on a receive frequency and you need to match the frequencies and yada yada, okay? There are a few things that they assume the technician knows to do. You've got to set this up so it receives, right? For your speaker audio alignment, they want you to set the power meter for an 8 ohm load. Wait, we did initial inspections, we used a 4 ohm load, right? But the alignment wants an 8 ohm load. I don't write these, I just read what the manual tells me to do, okay? I don't know why, I'm not entirely certain why the engineers went this way, but the alignment procedure calls for an 8 ohm load. Do it, okay? Understanding you inspected this on a 4 ohm load, but you aligned it on an 8 ohm load. Now it says adjust A3R163 for 7.5 plus or minus 0.1 volts RMS. So what they don't tell you is that you need to turn your speaker on. So you need to set this up for speaker, right? Because it's a speaker audio level adjustment. And then you need to turn the speaker on, all right? And then the next thing you need to do is turn the volume all the way up. Well, what have I told you about turning the volume all the way up?
Please don't.
You do it, see what you need to see and get off of it, right? So let's see where we're at. I don't have a speaker in this one. Huh. Oh wait, do I? I have something. That took a minute to take over. Am I receiving?
Dance,
Oh yeah, it's there.
dance.
All right. So I do have a speaker in this one. Yeah, I do, because there's the audio amplifier. And imagine that thing's nice and warm. Oh yeah. So I'm going to turn it up, see what I need to see get off, and it tells me to align R163. So where in the world is R163? Well, I don't have it drawn on my notes. I still don't have it drawn on my notes. Oh, I do have that. I forgot to transfer a note. Okay. This is my first proof of this, so give me a break. I have a few minor tweaks on this. So R163 is on the synthesizer board, and you'll find it real easy because there is one enormous transistor on this board, as I point at it with the non-metallic end, carefully, of the alignment tool. Let's go with that. That's Q5, that's your nav switch. That's the one that fails frequently. It's got 28 volts on it. All right, so you gotta be careful. This is R163, the one right in front of it. There's only 2 variable resistors on this board, okay? So what we're gonna do is we're gonna turn this, when we max the volume, on the 10 volt scale and set this for 7.5 volts. So when I turn this up, I should be able to turn this resistor and turn it down to 7.5 very quickly and then get off of it.
Alright, what did you do again? I was writing.
I turned the volume all the way up
Mm-hmm.
and adjusted the resistor till I got 7.5 volts on my Sonider, and then I turned the volume down.
Okay.
Okay?
A few seconds and that's it.
Yep, you want to get on it, make your adjustment, and get off of it. Unlike the VCO, you can't just tweak this, you'd be spend all day. So just turn it up, turn that to get to 7.5, and then turn it down. So when you go to do your inspection, it should pass, right?
So you're turning the volume all the way up, then adjust.
All the way up and adjust.
Okay.
Okay, it doesn't tell you on the alignment procedure because the manual assumes that you would know that. So engineers, I praised them this morning. I'm going to trash them for this because they tell you to do a thing, but they don't tell you fully how to do it.
Hey, we're
Yay.
getting better.
You gotta love engineers. All right. So that's the audio alignment. You're done. That's all there is to that one. Now we're going to go to the comm receiver alignment and adjustment. All right, this is the meat of this alignment procedure. I will tell you that I'm going to show you how to align a receiver. This goes for any receiver you encounter. This is how you align a radio receiver. I'll tell you, in the Army, when I worked on radios in the Army, which was not my specialty, but I was trained, field trained, I aligned the radio receiver for the FM radio the Army used at the time, Vietnam era radios. You might remember the RT-524, the RT-841, Prick 77. Remember those? You carried the Prick 77. You ain't carried. You don't want to carry a 524. That's 50 pounds of.
The giant man pack in the medium Alice pack?
That's the Prick 77, the RT-841.
It was heavy.
It was heavy. Oh, it's heavy. The 524 is the big one that went in the vehicle. Okay, you don't want to carry that thing. All right, it's 50 pounds of lead. And the radio receiver alignment for that radio was identical to what I'm about to demonstrate.
Wow.
So, comm receiver alignment. First step, you want to make sure your synthesizer injection at A3E2 is between 0.7 and 1.4 volts RMS across the band. So there's a highlight down here. Use the high frequency probe with the multimeter set on DC volts to make this measurement. Wait, what's a high frequency probe? This is a high frequency probe. I'm holding $300 in my hand. You break the tip off of this, I get to buy another one. Be nice to my high frequency probe.
Oh, I thought you were inviting that. Okay.
No. I have to make it very clear. Did you get that, Nathan? Don't break my high frequency probe.
Yes, sir.
What do
You
you
have to be
get
nice to this probe. Features of this probe: it's got a tip, it's got a ground line, and it's got a banana plug with one side labeled ground. Okay? You're going to take this and plug it into your multimeter. Into the common and volts port with the ground side on the ground side, just like that. Now, I can use this probe to measure a high frequency voltage level or amplitude level and measure it in RMS. And what I'm doing it says use a high frequency probe with the multimeter set on DC volts. How the heck am I measuring RMS with DC volts? The tool does it for you.
Wow.
It takes that high frequency, that 139.4 to 157, 400 something odd, whatever, okay? It takes that high frequency and converts it into an equivalent DC voltage that will be hopefully between that level.
That's
And we're going to measure that
so
A3E2. Okay, where is A3E2? Well, I'll tell you that there's only 2 cables that come up to this board, right? One of them comes up out of the synthesizer and goes over here to here, and that's A3E2. And the other one comes out of the receiver and goes over here to the synthesizer. Okay, so we're going to go look at A3E2 for your RF injection. When you go to ground this, you want to ground it to the very edge of the board. You got to be careful because there's circuit traces on this board, so be very careful where you ground it. All right. Sometimes you might want to find an alternate ground location, but you have to ground the probe. Okay. If you don't ground the probe, it will not work. Near one of these screw holes is a good idea. Okay. So I'm going to probe A32. I believe this is the center conductor. Nope, gotta be this one. And I'm getting, I should get somewhere around 0.7 volts. Okay, which one is it? Oh, that one was the center conductor, number 1. I just didn't probe it good enough.
Are those labeled?
Yeah, it's labeled 1.
Okay.
Okay. All right. And I'm on the wrong point. Sorry. A3E2 is here. That's your antenna coming in. No wonder I can't measure the antenna. That's what happens when you ain't taught this in 4 years. A3E2, there we go. See what I see? 1.4 volts. Is that between 0.7 and 1.4? That's well within specific. Matter of fact, it's a nice strong synthesizer injection. That's what you want to see. All I did was probe that. I'll do it again. I probed this point right here, and I see it. Now I'm getting 1.9. That can't be right. I'm not gonna be grounded well enough. If you don't ground well enough, it doesn't read right. There we go. Now I'm at 0.9. How in the world did I go from 1.9 to 0.9? All right. This takes an average of what it reads. Okay, now I'm at 2.3. Holy cow. All right. Why is my RF probe acting up today? Don't answer that. That's what you're supposed to see.
Huh.
Nice constant 1 volt or so. 1.4 was a little high, and 2 was way high, and
Could you use something like, I don't know.
no. Good idea, but no. All right, so that's where you're going to measure your synthesizer injection. All that is checking is your VCO sending your mixer, your local oscillator to your mixer, okay? And is it big enough to get mixed? So now, tells you to refer to paragraph 5.3 for overall operating conditions were already set up, just like you would for initial inspection. That's the same setup. The next step, step 3, it says set R180 fully counterclockwise and all of the other resistors fully clockwise, as viewed from the component side of the printed wiring assembly. Well. I thought this one had R201, it doesn't. So, where are these resistors? I see 1, 2, 3, 4, and some of them will have a 5th resistor up here. Which one's which? Well, you get a manual and you look it up. I have made a little cheat sheet for myself and put it on my alignment procedure. Do not copy my cheat sheet. All right, R180, fully counterclockwise. That's this one. All right. and then all the other ones clockwise, right? Why in the world do you do that? Well, what we have done
Center?
is taken the squelch out of the circuit, taking the AGC out of the circuit, taking the audio compressor out of the circuit, because that's what all you're aligning with those things. You need all of them out of the circuit so we get just pure receiver. Okay? If we do not disable those things, the receiver alignment is invalid.
I don't understand what you're talking about.
These adjustments. All these adjustments adjust those other circuits. So when you take 180 fully counterclockwise and these other three fully clockwise, we've adjusted them so those circuits aren't influencing the receiver. Remember, you had AGC that fed back to the RF and IF amplifiers, and you had your squelch, and you had your audio compressor. Well, we've disabled all of them
Wow.
By doing this.
by doing that. So all you're getting is receiver.
I want to see 4.
You know, there's a fifth one would normally be
Oh,
here
yeah, you said
on
that,
the
never mind.
upper level serial numbers. I don't have, I have a lower serial number here. I thought this one had R201. So we will not do these. We will not demonstrate the noise squelch alignment. I'll just talk you through it if we get that far. Okay? So what you're going to do, once you set it up and disable all those things by misaligning those 4 or 5 pots, you're going to go and tune the radio. This requires a little bit of sight and a little bit of sound. So you're going to have to hear this. It gets really weird when you got 8 people in here aligning this portion of the radio all at the same time. So you have to hear it, but you don't have to hear all of it. Once you hear it once, you can set it so you don't have to hear it anymore, and you can watch your sign adder. But for the purposes of the demonstration, I'm going to listen to it. I'm an old school guy. I just tune radios by ear. Okay.
That's so cool.
Yeah, I knew how to tune it. I knew how to hear it. Okay. Now you got a nice cool measurement so you can see it too.
That's
So, using the test setup in figure 5-2, inject in turn an RF signal in the comm antenna at the alignment frequencies of 119 and 135. So we're using a low and a high, but we're not on the ragged edge. Okay, so they don't want you using 118, they want you to use 119. And then 135. So you're just a little bit off of each edge. And something else you got to do is make sure you get out of the last thing we did. Because I'm still loaded for speaker, right? I failed to get out of my last test. This receiver alignment will fail miserably if I'm not in headphone. Okay? Make sure you get out of the speaker alignment and get back into headphone, right? And now you notice I'm not getting anything. I turned my volume up. I ain't seeing crap, right? I turned it all off. So I'm not receiving anything. So I have to adjust. It says adjust the comm off volume control to get 1 volt output. I'm not getting nothing. How do I get a volt? Well, I have to take my injection on the attenuator down a little bit. Okay, let me turn up my volume till I get something. Turn my attenuator down, and suddenly I'll start receiving something. They call this the AGC knee. You got to get it below the knee till you receive something. And I kind of want it on the higher end of that. See, you know, my needle goes higher and then peaks and goes down again as I turn the attenuator to the left. I want it kind of there, and you'll hear what I'm listening. This one doesn't sound really good. Let me do this. Why am I not?
You have a 150 on too. I don't know why.
Oh, that's not going to matter. I should be injecting 1,000 hertz, 30%.
Mm-hmm.
Sounds really bad, but that's 1,000 hertz. It sounds like something else, though, doesn't it?
Sounds like extraterrestrial transmissions.
Yeah.
Yes, it does. Sounds like something else. I'm not quite sure why. Okay. This may not align right.
It's the radio gods. What's sounding different? That it's not that clear.
That sounds like a broken horn.
Yeah, it's got
And we're
interference.
We're
Okay,
what?
that could be a function of the alignment. That could also be a function of a problem with the radio, which I did not anticipate for this demonstration. So we'll go through as if we hear a nice 1000 hertz tone. Okay. You want about 1 volt output using the vacuum tube voltmeter for the indication. Don't use the VTVM, use the sign adder. You want to turn your volume up to about a volt, right? You can hear it, and what we're going to do is align the RF stages, tuning the RF stages T1, T2, and T3 for the low frequency, and C1, C10, and C13 for the high frequency. So I'm going to need a ceramic alignment tool or a plastic alignment tool for the inductors, and a metallic alignment tool for the capacitors because they're metal. Okay, and I want to show you something else real quick. We'll pop this lid because it's labeled. Okay, pop this cover. You see T1, T2, and T3 are on the left. C1, C10, and C13 are I mean, the T's are on the right and the C's are on the left. Okay, so you do the T's first on 119, you do the C's on 135. And the idea is that you get them so you don't get either, you get them as good as they're going to get on both settings. Okay? You always do the receiver alignment with the cover in place, no matter what you see me do in the lab otherwise. All right. So I'm going to align T1 if I can. Oh, that's got the small end. So that's why I use this end of this alignment tool. And all I'm going to do is turn it, and I want to make it better. Okay, peek it out. When it peaks out, see that little peak I get? Watch the sign adder. Okay, turn it, it's off. It peaks up a little bit, and then it'll go away, right? It'll go back down. Well, now it's not doing that. Turn my attenuator down a little bit. Maybe I can see it better. Acted like it was going to do it, now it's not doing it. Great.
So how many soft volts are you wanting to work with on this? What range?
We're at whatever range the radio will tolerate.
At 1 volt?
Yeah, we keep it about a volt, and it's not mandatory that you stay on a volt. Volt's a good place to see. All right, as I turn the attenuator down, I get more noise and less receive, right? So I want to find that ragged edge where I'm getting a little bit of noise, and then peak T1. And hopefully, it'll actually demonstrate the alignment here properly. Turn it a little bit, it should peak out. This radio's not going to work. Okay?
What are you trying to see? It drop back down?
It should go down, go to a peak, and then go back down. Okay?
And that's when we stop.
So you want to peak it. You want to make it as high as you can. The goal here is to get the most as you can out of T1, T2, and T3. Okay, this radio alignment's probably there. T2 went down. I'm going to turn it back up. When it peaks out, turn my attenuator down a little bit. See if I can get more out of it. All right? It goes back down. So peak it back up. When it's at the peak, leave it. Get as much as you can. As much as indicators is a game of eaches, so is receiver alignments. That little bit could be what you need to make this thing pass an inspection.
So you're turning it down till it drops, and then you're going
Back up till it peaks, find the peak, go over the peak, and it'll go back down, then go back and find the peak. All you're doing is maximizing the output, peaking the output. I'm gonna do that to T1, T2, and T3, all right? And hint, they should be pretty close, unless the student before you really screwed it up, okay?
What are you recording down on this for this particular part?
See the needle? It's
Yeah.
down, and it goes up.
Okay.
Down is lower,
I don't think
or
there's
down
any
is
kind
left.
of precise measurement. I think it's
Up
just
is higher.
what the
Okay.
needle's movement
See,
is.
and it's small. It's not a lot. See, that's a lot. See how badly the receive function got dropped when I did that? Peek it. Okay. So hopefully you can find that sweet
Oh,
spot.
because the needle's hitting where it won't go anymore, and then it's
No, it's not maxing out.
no,
Never max your needle here. Okay, maxing those needles is bad. So that's 119. Let's go to 135.
So is this like for the AGC part that you'll be doing?
I haven't got to AGs. This is receive.
No, I'm talking about for when you're doing the test itself on it. Is that when you're setting the DBM, the 6 DBM, and you're trying to get the range of the function? Is that what that's for?
I'm just looking at the 1 volt scale, and it's not. It doesn't matter. I could do it anywhere on that scale. Okay, 1 volt's a nice convenient place to measure.
Well, I
Right.
was asking if it correlates
Yeah.
with that step whenever we're doing inspections. Whenever
Yeah.
you go through the ACG inspection
We're going to do
part.
an AGC alignment later. We set that specification later. Okay, that was a good question. I misunderstood your question. So I'm going to go to 135, and now I'm going to adjust the capacitors. Okay? And I have the wrong tool to do this. So I'm going to demonstrate doing the wrong tool, because the screwdriver will, see how it kind of cancels it out? So I can't use that tool. I have to use a plastic tool. Don't use the ceramic on the capacitors, you'll break it. Actually, no, I have the right tool. I have the tool I want right here. This is the tool I want. I want this tool.
The
All right.
tool is yours.
The tool is mine. And I'm going to adjust the capacitor. And all I'm going to do is just like I did before. Turn it. It gets worse. Peak it. And then go back to the peak.
Nice.
Bam. It was already aligned. I didn't have to adjust it.
No.
Next one.
You want T3?
I'm on C10.
Oh,
C10. The middle one. Peak it. Do 1, 2, and 3. And then do 1, 10, and 13. Okay, 1, 2, and 3 on 119, and 1, 10, and 13 on 135. Okay, now, all right, that was a little stubborn. You gotta be careful. If they're a little stubborn, you might tear up your alignment tool. You gotta be careful with it. All right. Okay, I found a peak. I get the peak. I'm pretty happy with that. If you ever peak it out, you can always turn your attenuator down to get more out of it.
Are you leaving it on peak?
I'm leaving it on peak, yeah.
Okay, is that what you're supposed to do?
Mm-hmm. Yep. So now here's the thing. If I made a big adjustment on one of these, because T1 and C1 work together, T2 and C10 work together, T3 and C13 work together. If I made a big adjustment on one side, I need to go back and readjust the other side. Okay? So you're supposed to really, if you do T1, T2, and T3 and you make a big adjustment, you do C1, C2, or C10 and C13 and do a big adjustment. You got to go back and do all three. You're supposed to do all three. In reality, you're probably not going to peak up the ones you didn't adjust much with their capacitor counterpart. See what I'm saying? So if you go through your alignment and you adjust, and T1, T2, and T3 are great, when you go to adjust C1, C10, and C13, C10 is way off. So you peaked C10 and C13 was fine. You go back, you're going to need to readjust T2. You're supposed to check them all, but in reality, they pair. Especially with this radio, they pair. Other radios may not behave that way. Okay? So that's one of those things that you kind of got to read the alignment procedure and understand how to do. All right, so we've done the receive alignment. All right. So now it tells you on step 4 to adjust the slugs of T5, T6, C7, and L4 for maximum phone output. All you're going to do is peak these. And it tells you to decrease the input signal as the output increases to ensure the signal levels below the AGC need. Less than 1.5 microvolts. We're supposed to be way down here, right? All we're going to do with this alignment, I'm going to point. You're making a U. You did T1, T2, T3, and C1, C10, and C13. Then you're gonna go T5, T6, T7, L4. You're making a U.
Nice.
T5, T6, T7, L4. Just like that. Okay? All you're gonna do is go to T5, and it doesn't matter what frequency you do this on, because now you're dealing with the intermediate frequency, which you learned this morning is 21.4 megahertz, right? You're just doing the same exact thing, right? Peaking them out. Find the peak, get it there. This one's got a little bit more spin to it, right? Some of them have a lot of spin, some of them have a little. If you find yourself turning any of these a lot, you're doing it wrong. See, I'm turning like a quarter turn. If you screw on it, it's going to fall outside the board. Okay? Just like the inductor adjustment here, these are the same way. All right? Oh, I got a little bit out of that one. If you ever peak it out a lot, turn your attenuator down. But hopefully these radios are pretty well aligned and they're all pretty close, and you just have to make minor adjustments. T5, T6, T7, L4. Just like that, make a U.
When you're
All right.
peeking these out, you don't want to go past 1 volt.
If you go past 1 volt, turn your attenuator down.
Okay.
See, if I peaked one out and I ended up there, turn the attenuator down.
Okay.
So you hear that noise?
Yeah.
Hear that shh in the back? That's
Oh.
I can tune a receiver by noise because I've done it by ear for so many years. You can get rid of the noise, max out the signal. Turn your attenuator down, get rid of the noise, max out the signal. The sign adder makes it simple because it gives you a visual indication and not an audible indication. The visual indication is also measurable if you choose to do so. Okay? So, it tells you to ensure proper tracking, the inductors and capacitors should tune with 2 peaks. Maximum. That's something that came out of the manual. I haven't seen a whole lot of that in execution. Just peak it. Okay? If you're turning C13 so much that you see 2 peaks, you've turned it 180 degrees.
Oh no.
Okay? These should already be aligned. I'm telling you how to cheat. Okay? Don't realign a good receiver. If your receiver fails the initial inspection, you're going to have to align. Okay? But if it's passing the initial inspection, all you're going to do is tweak it and make it better. Little minor adjustments, right? All right, now we're actually going to get into aligning your AGC. All right. So we're going to align the AGC. Connect your vacuum tube voltmeter to TP3. TP3 is this test point back here. And you're going to hook up your multimeter. Make sure you take out your high frequency probe. Hook up your multimeter to TP3. So again, I'm grounded at the panel, and I'm going to be set up and use my little clip. Okay, hopefully your radio has a test point. Some of these do not. If it's broken, then you have to manually probe it and do the alignment, which is painful. Okay, so it says set the signal generator to 126.45, 50 soft, 30% of 1,000 hertz. Why do we use 126.45? Because the radio likes it. And I want to set this to 50 soft. Where'd my receive go? It don't receive anymore. Because the AGC is not aligned right. We need to set the AGC so that it works right. Okay? All right?
Mm-hmm.
And you got italics talking about soft as half hard and a 6 dB pad. Half microvolts, 6 dBs. Slowly turn R39 counterclockwise until AC voltage peaks. That means I need to set my multimeter to AC. Because I'm looking for AC voltage now. This alignment is so easy to screw up. Because you have to read every word and heed every word.
I've been hearing this the entire time.
What?
It's a light
That's a
bulb.
lie. Yeah.
What are y'all
It's
hearing?
that back one right there.
All right. R39 is this fellow right here. All right. You can identify it using the board layout in the book. I did and wrote me a little cheat sheet, so it's nice for demonstrations. You're going to turn this slowly. See how slowly I'm turning this? I'm exaggerating my slow turning, okay? But you're going to turn it slowly, and you're going to turn it until you get a peak AC voltage. At some point here, your AC voltage is going to, your AGC is going to get involved, right? It needs to be on the 2 scale. All right, you see, I'm starting to see an AC voltage, and I could get close to 0.125, which is what I want, but I got to go past the peak first. So as you turn this up, it should go close to 3 volts, which I've just passed the peak at 2.7 or 0.27. And I'm going to go down slowly, past the peak, and then I'm going to get to 0.125. Notice how slowly I'm doing this. That meter takes a moment to count the AC volts, right? You see how accurately I was able to get it. If you do it quickly, you're going to screw it up every time. If you do nothing else slowly on this radio, the AGC alignment, so that it passes a final inspection, needs to be done that way and nice and slow. Take your time. Back to the receiver, you can go through and peek and see and get that really quickly. Okay? AGC, take your time. All right? I can't emphasize slowly enough. All right. Note says there are 2 settings that will give you 0.125. The most counterclockwise position is the only correct setting. All right. Now we're going to check something. Signal 12645, 10,000 hard. That's 5,000 soft. All right. And then set the volume control for 1 volt output. Use the 1 volt scale on the sign adder. I want exactly 1 volt. At this point, I don't have to hear that anymore. All right. Reduce the signal generator to 5 soft. It says 10 in the book. I'm going 5 soft. All right. And adjust R180 counterclockwise until your headphone output is 0.5 volt. R180 is the other one in the corner beside it. And all I'm going to do is set my headphone volume for 0.5 volt. This sets your headphone volume. Okay, you turn it. Ooh, it drops out real quick. This one's real sensitive. Some of them are and some of them aren't.
0.5 volt on the sign adder.
Very good. 0.5 volt. That's 1. That's 0. So that's half on the 1 scale. Okay? So now you've set your headphone volume. Can't set the headphone until you get past AGC because you're not going to be right. Okay? Speaker, it don't care. All right? Headphone matters. All right? So it tells you to repeat T7 and L4 for maximum output and minimum distortion. Okay, that's these last 2. If you feel you need to do so, you can go here and peek these out again and then readjust R180. Okay? If you think you can get a little bit more out of it, und I did. You see that? Because now we're messing with the IF frequency. We've got AGC involved and it's aligned and it's proper. Okay? So now we're going to see if we can get just a tiny bit more out of it. That's the whole game in the receiver, right? Just like your nav indicator, every little bit matters. So I got a tiny bit more out of it. I'm now going to tweak R180 again. Make sure it's right at 0.5 volt. So that's the alignment.
Nice.
All right. Now it tells you to do something else. We're going to check the pass band. Oh, this is a fun alignment. This one needs coffee. All we're going to do is we're going to set we're still at the 5 microvolt, or we're going to set this to 2.5 microvolts. Okay. 2.5. And we're going to slowly tune the signal generator through 126, through those 2 frequency ranges, and observing the phone output for the pass band. I want to set the sine adder for about -6 dB. So I'm going to turn up my volume until I'm on about -6 dB. And then I'm going to use the variable function of the NAV750, and I'm going to set to 126.443. So when I go out of vary,
What?
I want to go to 443.
You got this memorized?
It's written down. Okay,
Sarcasm.
it's right there. 126.443. And I want to go slowly tune to 126.457. So I'm going to slowly turn this back up, watching my sine adder, and it says I should see less than 4 dB difference. So hopefully, I'm really right now at like 4 dB, because that'd be 6, 7, 8. I'm at 11, so I'm at 5 dB. Okay, but it's real close. So if I turn this, see, it jumped up just now, didn't it? Just a tiny bit. Right on the edge of 443, I get really close, and I'm gonna take this slowly up as I watch my sine adder. 4.5 is where I'm supposed to be. 4.57. I'm right at 4.57, and it says it should vary less than 4 dB. At 4.57, I'm at 4 dB. Okay? I can tweak T5 and T6 a little bit if I choose to make this better. All right, I'm right at the edge right now. So does tweaking T5 or T6 help? A tiny bit. Sometimes this alignment makes a whole lot of difference. Sometimes it doesn't do crap. Okay?
Dog crap?
I didn't go that far. I didn't specify. You know, I didn't say I knew crap. Okay? All right. So hopefully, when we go back and go back to 443, when you get to the ragged edge, you're going to be right at the edge. This one's not really good. Okay? Most of the radios you'll encounter don't move all that much till you get past like that. I'm at 438, I'm out of spec. Okay, this puts the pass band, so if you receive something that's close, you're gonna process the good signal, right? Because there's 450 right now, right? Okay, and then back to 457. All you're checking is to make sure you're about no more than 4 dB out. And if you're really close at the very edge, you're probably okay. All right. When you get done, lock your frequency back, and you should be fine. We have now set your AGC, and we have set the passband variation. All that is a check, but you can tweak these if it's bad. Okay.
Tweak what?
T5 and T6, like I said. Like you tweaked T7 and L4 earlier for the phone output. Okay, you can tweak them just a little bit. That's fine tuning the IF. We coarse tuned the IF on the front end. Now we're fine tuning the IF. Then we go to squelch. All right, we're almost done with the receiver. We got 2 more things to adjust. Squelch. All right, set the front panel squelch control to its extreme clockwise position, all the way to the right. Skip step 2. Notice it's blanked out because I don't want to max my volume. It's a wasted thing because the next thing I'm going to do is set my volume to a certain level. Apply a standard COM input of 5 microvolts soft and set the COM off volume for 1 volt on the VTVM. Use the 3 volt scale and set it to 1 volt. I think they want you to max it so you max your voltage one time, but I don't necessarily do that step because it doesn't necessarily matter that much. Okay? Set your voltage to 1 volt. Set your front panel squelch control to its extreme counterclockwise position, and then you're going to adjust the squelch range for a squelch threshold of 15 plus or minus 2 microvolts. That's hard. So I've got to go 7.5 plus or minus 1 soft. See, I got to convert my specifications. Okay? So I'm at 5. I got to squelch this radio between 5 and 10. 7.5 is halfway between 5 and 10. Okay? So I'm going to take my alignment tool and I'm going to adjust my squelch alignment, which is this one. I knew that. R61. It tells you to adjust R61, right? And you're going to adjust it. Okay. Make that change. A6 R61. Not R21. There is no R21. I have a typo. I have a couple of typos in this procedure I need to fix. I don't make many mistakes, but this one has a couple in it. All right, so all you're going to do is turn this. Now I'm going to do this rough real quick because I can do this one on this. So I'm going to turn this resistor, right? And suddenly you're going to see your audio drop out. See that? I turn the resistor and I can pass audio and I can squelch audio or mute audio, right? What I want to do is cheat. I'm going to turn this up to 7.5, right in the middle. And I'm going to take this squelch adjustment and take it to just the very edge of when it breaks and blocks audio. Nice and slow, and then it'll suddenly drop out. And then I'll find the ragged edge when it passes, ragged edge when it drops. And somewhere right there, right on that ragged edge, you guys have done this in the indicators 100 times, right? Find that sweet spot and leave it right there. If you go too far, you're going to be out of specification. So when I'm below 7.5, I should have no audio. As I cross through 7.5, I got closer to 10, so maybe I need to go the other way. Maybe I need to find the ragged edge of where it comes on for this one. All right. Okay, which way do I have to turn it now? There it is. Okay. All right, so when I turn it down, it cuts out. As I come through 7.5, passes audio. And as I go back through 7.5, plus or minus 1, it breaks. It blocks audio. See how accurately that is? There's 7.5 on the way up, and there's just a tiny bit less than 7.5 on the way down. That is perfect. That's what your squelch alignment should look like.
Nice.
All right. The check you do after is set front panel squelch control to the clockwise position, and with no signal applied, check that the audio output is not squelched. Okay? So I just want to hear audio, right? And if I take the signal off, I still hear shh. It's just a check. Okay? Make sure you didn't over-align the squelch.
Wait, what was 6?
Then I also check.
We haven't gone to 6 yet. That was 5. The next 2 steps are for radios equipped with the noise squelch adjustment R201. R201 is not equipped on this radio. So I'm going to describe this real quick. Okay? I will demonstrate it later because my next alignment, I'll have the actual radio with the right stuff now. So we're going to go ahead and set your RF signal generator to 200 microvolts. So I would turn the attenuator up to 100 soft, right? Okay, which is 0.1 K for those people who are decimally challenged. All right. Then I'm going to have 30% modulation, 7,000 hertz. There is no setting on my NAV750 for 7,000 hertz. So what I got to do, those of you who've been through my components class know what I'm about to do. Turn off my 1,000, because I don't want it interfering with this alignment. I'm going to take my audio generator and turn it on and set it for 7,000 hertz. You're not going to get this thing dead on. You get it close, okay? And I'm going to inject audio from the output line with this little cable that conveniently lives on top of my audio generator. Okay, it's here for only one purpose, to make this connection. You're going to run it into the external modulation port on my NAV750. When I connect it, you see my modulation jumped up, right? Okay, you see that on the 750? I'm injecting 7,000 hertz into my radio right now. You want to set that at 30% modulation. So you turn your attenuator up here until you get 30%. All right, that's what it tells you, I think. 30% modulation. Set the front panel switch fully counterclockwise, like the radio would be squelched. And you want to adjust the frequency for a maximum negative voltage on TP4. Well, this one don't have R201. It obviously doesn't have TP4 either, okay? But you would adjust your frequency until you saw a negative voltage, the highest negative voltage, right? That's where this radio is most sensitive to noise. It uses 7,000 hertz as a reference approximately to determine what noise is. And it's approximate. So what you're doing is turning this frequency to the point where that LC filter that we're, or RC filter we were described in the squelch circuit would be most sensitive to noise. Okay?
Get out.
And then you're going to adjust R201 until squelch just opens. You're going to be able to see audio appear on your sign adder. Okay? And there's a note, you've got, this thing is very generational. If you've got a radio that's got R201 but it's not 40,000 and above, you might have a different specification, so you got to play with it. Okay? So it will depend on which radio you got. All right? That's the noise, that's the squelch alignment. I think that's all of it. Yep. So I'm going to disconnect this and get out of this test real quick. I will demonstrate this again when I do this for the other group, okay? And when I do, we will get the opportunity to actually do it because I'll have a radio with R201. I chose this one because it's conveniently open, right? And it only has one alignment that doesn't work. We know which one that is, don't we? Mm-hmm. And we're not getting there today. I don't think we're going to get to the nav. All right, so audio leveling. All right. Make sure we're injecting 1,000 hertz again. 12645, 50 soft, 30% of 1,000 hertz modulation. So I'm going to go to 50. All right, and adjust my comm volume control for an output of about 1 volt RMS. Okay, there. It says use the 3 volt scale on the sign adder and set to -6 dB. Cheat. We're going to cheat. All right. Set the signal generator modulation to 95%. Holy cow, how do I get that? Well, I can turn my 1,000 hertz all the way up. That's going to get me to 60.
Cool.
And then I can turn my master mod up more, get me to 95. Holy cow. I'm maxing my scale. I gotta turn that down. All right. Adjust R46 clockwise until the phone output is the same at 30% modulation. All right. R46 is the only other resistor you haven't touched. It's right here. I'm gonna turn that down. Okay. Go back to the 3-volt scale. I'm gonna turn this down until it's about -6 dBs. You don't want to do this alignment too many times. You want to get it right the first time. All right. So at -6 dBs. Set the signal generator back to 30% and set the volume for about 1 volt on the VTVM or the sine adder. So put this all back in at 30%. Okay, well I'm at a volt, right? I like the dB measurement, so I'm gonna go to -6 dB. I turn it up a tiny bit. Then it tells you to go back to 95 and make sure that it doesn't increase more than 4 dB. That's why you use the dB scale. So we'll go back to 95. Did that go up more than 4 dB? I see 2. You see how I got 2? Because it was on -6. 1 tick, 2 ticks is -4. All right. That's done. That's audio leveling. It's that simple. Okay? So when you get done with the test, get out of it, right? All right. The next test is the COM transmitter modulation alignment. Oh my God. We've got to transmit. So that, you know what that means, right? We've got to use the transmitter and properly load our transmitter. This will be the last alignment we do today. Disassemble the receiver transmitter only to the extent necessary to gain access to the test point. So what you got to do for the transmitter alignment is you're going to have to turn the power off. You got to get into the transmitter. So we're going to roll our radio onto the side like this. I've got a loose nav receiver here. This is for another reason. Yep. You know, radio is disassembled for other reasons. I don't need that flopping around. So, all right. You're going to take the 6 screws out of the transmitter cover. There are 6 metallic screws. You may see 2 plastic screws. Leave them alone. They are there for another purpose. We're going to go in and take a look at our transmit modulator and our transmit RF amplifier and all of those things that we talked about before but we didn't really get to see. Watch out, there may be washers. Don't be a lazy technician and leave me a pile of washers on your bench. If you find some with screws without washers, that means lazy technicians have been in ahead of you.
Round side up or round side down? Round side up.
Probably. Okay. Remove it. You'll notice it had
Something.
I had a washer. I missed. That's the wrong washer too. It's not supposed to have a lock washer. At any rate, you see this shield to shield your transmitter, and these two dudes here are heat sinks for those 2 big modulator transistors, right? Okay. So you want to make sure that that is covered and the heat sink is present when you transmit. So in the drawer are a couple of these little test jigs. Cessna used to sell an actual test jig. This is a transmitter cover that's been cut off, okay? But it serves the same purpose. You need to place this over these 2 transistors because they get really hot if you don't, okay? You burn up those transistors. It is a significant emotional experience to take apart this transmitter, okay? Because you have to literally disassemble this, take all of this stuff out, remove wires coming from the antenna and the receiver to lift these boards out to change those parts. It's painful. I have one I'm working on the other side, and that's why it's still open, okay? It's painful and it's time consuming. So you want to not burn up the transistors if you can help it. All right. And it tells you about the, under the caution, and my little note, use provided heatsink cover. Connect the receiver transmitter to testing as shown in 5-2. In other words, connect it like you're going to transmit. Terminate it properly. All right. Connect the audio signal generator and voltmeter. Input voltage is 27.5 volts, so you can turn it on, right? Okay. Duty cycle should be observed. Maximum of 1 minute keyed and 4 minutes unkeyed. 1-to-4 ratio. If you turn this thing on and let it on for a minute, I'm going to be looking at you hard after about 10 seconds. All right. These are old and they're lab radios, so you got to be nice to them. And then it gives you a definition for average modulation, which is the formula we use for percent modulation, okay? There are 3 alignments. It tells you to set A4, A2, R4 to the midpoint of its adjustment. That's this one. Notice I have a cheat sheet here. Right? This is R4. This one has to do with transmit voltage. Find the middle point of the pot and just set it in the middle somewhere. Right? Connect a DC voltmeter to A4 FL2. FL2 is labeled. It's this filter, and you want to be on this side of it. Trust me, you want to be on this side of it. You want to very carefully measure that while you're transmitting. Now remember, we're measuring for what? 13 volts DC. So we need to set our multimeter up for 13 volts DC. DC volts, 20 scale, all right? All right. So I'm going to, it tells me channel 12645, I'm there. And then depress microphone key and adjust R4 for 13 volts. So first thing I'm going to do is turn this on and see where I'm at. I'm at 11.7, so I need to go up. Well, I don't know which way is up, but clockwise usually means up, so I'm going to turn it up some. .7, 12.8. Leave it on for a few seconds. It'll probably continue to climb a little bit. All right. You can do this in live in real time while it's keyed. If you're fast enough, you'll have me looking at you though. 13 volts. All right. Notice I got the 13, right? Plus or minus 0.1. It's going to dodge a little bit because you remember you got the modulation injected as well. So you might have a little variance there. Okay. So, the next step, it tells you to adjust C12 and C15 for maximum power. Notice it's all lined through. We don't need to perform this in the lab. It affects both power and frequency, but only a minimum level on this model radio. So adjusting these 2 capacitors while you're transmitting, it's supposed to help. Really doesn't much on this radio. Other radios you might have to adjust the capacitors, or you might have to adjust the coils here, and you would do that with a non-metallic tool and expand or contract them to get them on frequency and get the RF power out of it you need. I've had to do that on some radios, okay? For the purposes of this, don't mess with the power alignment, okay? If you got a radio that's really badly out of power alignment, I will help you, okay? So we're not going to adjust these 2 capacitors. Leave them alone. So the next thing we're going to do is modulator alignment. We want to set R3 counterclockwise and R33 clockwise. Okay? So R3 counterclockwise, it's all the way down. R3 clockwise, all the way up. All right. I want to go to 118.5. Not sure exactly why they have me do that, but that's what I'm going to do. Now here's where we get the differences between the 40,000 and above and the 39,000 and below radio. This is a 39,000 and below radio, so I'm going to go to step B and apply half a volt. If I go to step A, if I got a 40,000 above, I got to use step A and only apply 0.125 volts RMS from my sine adder to my mic jack. So I'm going to flip this to the left, set this on the 1 scale, and turn this down to half a volt. Okay, where's my, oh God. When we work later, remind me to clean the pot on this one.
Okay.
Scratchy. All right. So, depress mic key and adjust A4R3. I wrote 23. Make it 3 for 50% average modulation. Okay, so we're going to adjust R3 for 50% average modulation. So we need to be able to read modulation. If you're doing on the 401L, you need to read your peaks and valleys and do your math. Okay? And really you don't. Okay? If you have one that does it automatically, you can key the mic and turn this for 50% average modulation. So notice I got my alignment tool in the resistor already. I'm going to key it up, and then I'm going to turn it really quick until I get 50%. And that's not reading. That's not reading modulation for some reason. So I'm on the right setting. Oh, I'm on the wrong frequency. Let's try it on the right frequency.
That's nice.
Huh. There. Works when you're on the right frequency. Set it to 50%. Get it close. If you're using a 401L, get it so the peak and the valley are about half of each other, ish. You don't have to get super accurate there. Just kick it up till you get something. Okay? All right? And then increase the audio level as defined below, and adjust R33 for 100% modulation. Okay, if you're using the peak and the valley method, you want to adjust it until the clipping at the valley of the carrier just vanishes. In other words, you'll see the peaks like this, and a valley will be really short. Okay, if the valley is really long, that's too high. You got to adjust that valley as short as possible, okay? But you want it low but short, okay? For this one, all we're going to do is set it to 100, but we got to turn our volume up till we get 2.5 volts out of our audio generator. So here's where we got a problem. Our test equipment doesn't do that. It's the one limitation we have with the sine adder. So I'm going to set this to the 3 volt scale. I'm going to turn this all the way up. On the 3 volt scale, I'm getting almost 2. All right, I'm going to go within the spirit of the alignment here. I'm going to go within the intent. Okay? Which is not what you're supposed to do, but we have a limitation here. So we're just going to understand we are only maxed out so far. All right? So we're going to adjust the R33 for 100% modulation. All right. So you want to get it so the valleys are not, or smooth. Max out your modulation. So we're going to go ahead and kick this up. And I'm going to turn this until I get 100%. Well, I can't get 100%. It won't go. All right. So I'm gonna leave it. All right. I didn't leave it maxed. I took it just a little off of max. Okay. So now it says connect a modulation meter in place of the O-scope, key the transmitter, and check that you get average modulation 85% across the band. Okay. So the procedure doesn't tell you how to do that. Okay? You notice my italics comment there. Ensure the radio will pass an initial inspection. Adjust R3 and R33 to achieve the best output. So if you're watching your peaks and valleys, you want to make sure you don't have a big fat valley, but you also need to get 80% modulation, right? And they say greater than 85. So that's where that 85 number came into my head. So what I'm going to do is I'm going to take and adjust R3 again. Now that I've set R33, this one didn't work really well, but you're supposed to. Okay. Now I'm going to set R3 and make sure I pass an initial inspection. 85 or so. Okay. That almost concludes the transmitter alignment. If you have a 40,000 and above radio, you need to go set your voltage again. Okay? If you don't have a 40,000 and above, you're done. All right? The only thing we need to align now on the comm is the side tone. All right? So and we're going to do the 39,000 and below on step 1B, half a volt. And want you standard speaker load. So they want to do this with speaker load. So we need to get to where we can align something on the synthesizer board again. So before we go any further, get out of the transmitter test. I don't need to disconnect that. In other words, remove your test jig because someone else is going to want to use it, right? Mm-hmm. Notice I did all that with the power off. Everything's off. Okay? Because there's 28 volts live in here, a lot. Okay. And then when you key it up, there's 28 volts in even more places. Replace the transmit cover. Put all your screws back in it. Okay? So this will take a moment. Take your time and do the right thing. Okay, put your screws back in it. And then we're going to go ahead and do this side tone alignment, and that will conclude the comm. Okay? Does anyone have any place to be?
Not till 1.
Not to 1. Okay, well I got lunch to eat here in a few minutes.
Oh yeah, I got a ham sammy.
Ooh, baby, that sounds good.
I need brain food. So.
I got salad. My wife made a chef salad last evening.
Yeah.
So I have a big old chef salad to eat. And a big old chunk of.
Made by a chef.
Actually, yeah. Mm-hmm. I will credit her as the chef. She does all the cooking. I do all the baking, which I don't bake very much because she's an acceptable baker, but for some reason I'm not the cook in the house. But you want some cookies made or you want a pie crust done, I'm the guy. So I know we needed that on the video. All right, so and that will come back to haunt me later, I'm sure. All right, so now we're going to go ahead and set this up for a speaker load. Okay. And again, I should put that in the middle. And we're going to go for 8 ohms because that's what they want for alignments, right? It's for side tone. Dummy microphone voltage. And they want speaker 8 ohms because the speaker circuit does the side tone. All right. If you don't have a speaker, this may not work. All right. So we're going to have half a volt injection, like we are. No, we're on the 3 volt. We're maxed out. Turn that back down to 1, half a volt. All right. and you're checking that your side tone should be greater than 0.25 volts RMS with the standard speaker load. So I can turn my radio on again and transmit. All right. So I'm going to go ahead and go back over here. I flipped it, so I've got it set up. I'm injecting that 0.5 volt, but I'm going to monitor here, and I should get more than that, 0.25, when I key the mic, or side tone voltage, right?
Mm-hmm.
So let's hope we do. Oh yeah,
Okay.
I get all of 0.7.
Yeah.
So pretty close to 0.7. So that's great. It's just a check. If you don't have a speaker, that step may not work. Okay? It says remove standard speaker load. Put your switch in the middle. Go back to headphones. A headphone load of 500 ohms, right? So the speaker side tone check was just a check. Okay? Now we're going to adjust R183 across the standard phone load based on the specifications below. Now they want you to apply a 1 volt signal for a 39,000 and below radio. So now I need to go back over here, turn this up to 1, and then monitor it. And I'm going to key the mic, and I want to adjust R183, which is this one, the only other one on the bottom board. At this point, it should be the only other resistor you ain't touched, okay? We'll say it that way. And all you can do is very carefully key the radio and set this for apply that, and it doesn't say. Excuse me. I have a typo on my procedure. Ah! That's why I'm playtesting. Adjust R183 for 0.5 volt. For, as it says, for 0.5 volt across the standard phone load. 0.5 volts RMS. Plus or minus what? Plus or minus 0.05. Okay. So I need to make that change to my procedure. I missed it. So all we're going to do is key the mic and adjust this resistor for 0.5 volt. We're on the 1 volt scale. Let's hope we're close. We should be close. And I get nothing. How about if I put the headphone switch in? Huh. Oh yeah.
Wowza.
Oh, that's a lot. I can't get it off of it. One more time. I'm gonna turn it down. Well, I can't get to 0.5 volt. I'll check my alignment procedure for that. Okay. And I'm wondering if I've got my specs wrong. At any rate, let's see what I have over here.